Let's make this a little bit more dynamic. The section is called More Dynamic CPR Experiments. CPR, of course, is our common pool resource experiments that we've been looking at. So far, the experiments all have the following sequence. One is that participants each make private decisions on how much to appropriate from the CPR by investing tokens or time in appropriation activities. Secondly, when everybody has made their decision, the aggregated information about the consequences of the decisions of the group are shared with the participants. So if you started with an amount of fish, everybody knows how much was harvested and so on. Then a new record starts where the participants have the same payoff information. So everybody knows how much money everybody made. In reality, people make decisions all the time. Some make more decisions than others, and some decisions cause immediate consequences. For example, if the irrigator takes too much water upstream, downstream irrigators immediately experience a shortage of water. To better approximate real-world decision making, new experiments were developed using computer simulations where participants make decisions in real time in a spatially explicit dynamic environment. So this paper describes it, which includes, of course, Eleanor Ostrom and Marco Janssen. This experiment includes more realistic ecological dynamics. Will the results of earlier experimental designs still hold in this more dynamic CPR experiment, spatially explicit and so on? So here is a spatially explicit resource. You have 1, 2, 3, 4, 5 as the let's say number of people, and then you have grids with no stars, whatever they are called here. The results of the experiment show that, oops, I skipped all the tokens. So each grid box has a token or not, and when people harvest, the tokens are gone. But if the neighboring grid cells have tokens, then the grid that has no tokens will grow tokens, and this has explicit boundaries, so the boundary grids have no tokens on this side, so they are limited based on their location, interior or boundary location, and so on. Okay, so the results of the experiment show that we see a tragedy of the commons in experiments without communication or costly sanctioning. So this went on, this is repeated for some time. Maybe I should read it a little bit more explicitly. I don't know why I cut out all the texts on it, or I can include the text and continue, I guess. So we talked about costly sanctioning. We talked about, so here what happens, let's consider this more complex environment in a bit more detail. The participants collect tokens from a shared renewable resource environment. Groups consist of 5 participants that we just looked at, 1, 2, 3, 4, 5, who share a 29 by 29 grid of cells. Borders are not wrapped around, so that's the real edge there. You don't, it's not like a periodic boundary condition. At the start of the experiment, 25% of the grid space is filled with tokens. Thus, 210 tokens are randomly allocated on the board. Each participant is assigned an avatar, which they are able to control using the arrow keys on the computer keyboard to move up, left, right or down. So it's like a video game. The avatars are initially placed in the middle of the row of the screen with equal distance between the avatars. When the participant wishes to harvest a token, they must position the avatar on top of a token and press the space bar. So here are the tokens. You navigate yourself to the on top and then you press the space bar. Okay, the avatars are initially placed in the middle row of the screen with equal distances, middle row of the screen, with equal distances between them, then you can start moving and start clicking on the tokens to harvest them. Each token harvested is worth a certain amount of money defined by the experimenter. Participants have complete information on the spatial position of the tokens and can watch the harvesting actions of other group members in real time, so the entire screen is visible to the participants. Furthermore, they can see the total number of harvested tokens of all the participants at the top of the screen, so a number will be shown which counts all the tokens harvested. Every second, empty cells have a possibility of generating a new token in the same way that land can generate new resources over time. So that's the ecological metaphor. The probability PT that a given empty cell will generate a new token is dependent on the number of adjacent cells containing tokens. The probability PT is linearly related to the number of neighbors. So PT is P times NT divided by N, where NT is the number of neighboring cells containing a token, N is the total number of neighboring cells. So if you're in the middle, you have 8 neighbors. If you're here, you only have 3 or 4 neighbors, and so on and so forth. Okay, let me make sure I read that correctly. So n equal to 8, p is 0.01 can be prescribed. If an empty cell is completely surrounded by 8 tokens, it will generate a token at a higher rate than an empty cell that abuts only 3 tokens. Can you think of ecological equivalent of this process? So basically you have a forest which is got a dry patch, timber logged, or you have a desert next door, or urban settlement, rural settlement, whatever. You can imagine many situations, right? Okay, so the model space is not toroidal, so cells locate at the edge of the screen have fewer neighbors than the interior cells. For example, a corner cell has only 3 neighbors. At least one adjacent cell must contain a token for a new generation of token to happen. Therefore, if participants appropriate all of the tokens on the screen, they have exhausted the resource and no new tokens will be generated, i.e. they have caught every last fish, so there are no more fish to reproduce and the fish population becomes extinct. So you can also think of these as fish left to breed, or you removed all the fish that can breed. By designing the environment in this manner, the experiment captures a key characteristics of many spatially dependent renewable resource. Okay, so I will include that next time I do this. I don't know why I didn't include it. Anyway, so the results of the experiments show that we see a tragedy of the commons in experiments without communication or costly sanctioning. Within 2 minutes, the individuals have collected the last available token on the screen and spend the remaining 2 minutes of time in the round staring at a black screen. Okay, so the screen becomes black if we look at this in a minute. If we repeat this situation, we get the same results. So people keep doing the same thing. This means that there is no learning that might avoid the tragedy of the commons in this situation. If we allow participants to chat for a few minutes, the performance is significantly increased. We can see this in figure 9.6 since the resource stays at a higher level, leading to more regrowth of the resource. In the next slide we'll see this figure. So communications help cooperation. The earnings increase from 53 to 94 tokens per round per person. It's a remarkable jump, almost double. Note that here the participants do not communicate face to face, but only exchange messages via a text screen. Nevertheless, the group can achieve a result that is substantially better than without communication. Interestingly, however, if we allow costly punishment, we do not see an improvement if it is not combined with communication. So communication helps. Adding costly penalty doesn't help, so communication is still the key. Because participants are afraid of retaliation in this interactive environment, costly punishment alone is not effective. These experiments show that communication is much more important than ability to sanction each other. Punishment is not necessarily a deterrent, whereas communication allows them to work better together. And the idea, as we'll see, is that once you start communicating, you feel like you are part of a group, and then the group dynamics and the sense of responsibility, sense of equity, and so on seem to naturally take hold. So here is the resource size. Without communication, they quickly exhaust everything and then just sit and stare at the black screen. But if communication is allowed, then they harvest sustainably for a while, and then eventually they exhaust the resources. So resources are lasting much longer in this case. Does it mean that tragedy of the commons is inevitable? Not necessarily. We'll see later. The resource size, or the number of tokens over time for rounds with and without communication. Here you are assigning the probability of regeneration and rules for regeneration. There is a finite resource in terms of the boundaries, and how the tokens get regenerated depends on the density of the tokens, and so on and so forth. So maybe this is too short, but we will move on to public goods. Maybe it's not so short. It is 11 minutes, so maybe I should leave this here and come to public good action situations in the next podcast. Okay, so we basically looked at the common pool resources with different set of rules and made it more complicated, more dynamic, with resource harvesting and regeneration and the role of communication. So you learned some lessons there. Common pool common goods, public good action situations, of course, are something like generating Wikipedia or something else that is beyond just harvesting a common pool resource. So we'll come back and look at that in the next podcast. Okay.